Why did you move from the PG? Okay, today we're going to start. This unit's a lot about radicals. Okay, radicals. How radical is that? Totally true. I love me some Red Turtle back in the day. Okay. So we've already kind of talked about radicals. We've worked with them a little bit, but we worked with single radicals. First off, let's break down a radical. Happens every time in this class, doesn't it? What? 7-3 and 7-3. That part's 7-3. You need a binder? I have extra. Would you like just a binder in general? I got, hey, Ani! What? I have it. Got it. Covered. Hey, Alex. Here's your own one. Now, you might want to get rid of the stuff that's already in here, but maybe somebody has a scribble pin. Oh, this is the same thing. Anyway, it's nothing. Yeah, maybe it has like a journal. Nitty-gritty of their life. Okay, 7-3. Here we go. So, what about the square root of 48? What can we do with him? I'm going to work on a factor tree exactly. Okay? So a factor tree. A lot more people not being right? Touche, huh? Okay. The cow? The cow. I said the cow. What's in 48, Madison Dunn Nisper? Did you say K or 6? 8? I'm struggling. No, that's what I was. What's in 8? 4 and 2. What's in 6? 2 and 3. And 4 is 2 and 2, right? Notice, because it is a square root, I'm looking for groups of 2. There's a group of 2. There's a group of 2. Hi-ho, hi-ho. So that is 2 times 2 times the thing that didn't get circled, 3. So this is the same thing as 4 root 3. Hi. Okay, so let's say, like you said, that would be square root of 96, if we'll just do that really quick. 96 is the same thing as 2 times 48, which is 16 times 3, which is 4 times 4. Look, I'm going to stop right there. It's already got pairs, don't I? If I already see pairs, should I break them down more? No. This time, I already got 4. But this guy didn't get circled. This guy didn't get circled. Right? So I have 4 square root of 2 times 3. Answer your question? And we should have been able to do this in previous years. Whoa! You had to dig it a little bit because I can only get the other Allison. Well, because it co-cocted right it was. Usually I have a nice lock. Usually, but I had a zinger because she was kind of other Allison was a little bit in the way. Okay. Are you gonna get on? All right, Al. Thanks for being a nice person, Al. on primitive. Okay, square root of 5 times the square root of 3. Square root of 5 times the square root of 3. Can I multiply when they're the common radical? I can. So this is the square root of 15. Oh, hey, hey, hey. Oh, hey, hey. Like this. Yeah. No. Like I could do this. 2 cube root of 6 times the cube root of 4. I can't. That would be 2 cube root of 24, which I can break this out of. Notice I can't because they're like radicals. Because they're both cube roots. So therefore I can multiply the items underneath. Guys, there's lots of talking today. Maddie. You'd multiply the numbers on this. So watch right here. So I'm going to break them down because I can break them down. 6 and 4, which we just saw, right? Nope, 12 and 12 are 144. What happened? But this time it's a cube root, so I'm looking for groups of 3, which is right there. So there's already a 2 outside, and then I'm bringing out a 2. So I have 2 times 2 cube root of 3. What is 2 times 2 though? 4 cube root of 3. Does that make sense? What about this guy? That's horrible. I'm going to show you. Can I currently, the way I just showed you, can I multiply these guys? Why? They're different radicals. I have a square root and a cube root. Agreed? Now let's go back to something we learned at the beginning of the year. Remember, we went from radical to exponential, didn't we? Exponential to radical. So let's make this as an exponential. This is 6 to what power? 1 half. Remember, first power, second half. Now, I can do this 2 ways on this guy. Can I break him down? What's 25? Isn't that 5 squared? Okay. It's just intriguing. They're like, we don't want you to see what we're doing. We're putting clear red. I know that's what that is, but my reasoning was good too, wasn't it? Isn't 25 5 squared? So how could I write this? 5 to the 2/3. You guys agree with me on that? Okay. Now, what radical could I make them both be like? The 6th root, could I make both of those fractions be a same denominator of 6? Where 6 is being raised to the 3/6? That's the same thing as 1/2. Would you guys agree with that? If I wrote this as 6 to the 3/6 times by 5 to the 4/6. Because those are, they're not, hi! How are you? No, I'm coming right now. Give me a second. Okay, so with that being said, now I can put them under. This is the 6th root of 6 cubed, which is 36 times 6. I just did 6 cubed. Oh. Now I'm doing 5 to the 4th, which I believe is 625. And then I multiply those, and I have no ideas. 135,000 straight up? Oh. Okay. Nice.
It's a perfect 6 group.
Is it a perfect 6 group? No. It can't be a perfect 6 group. I'll tell you why it's not a perfect 6 group. Because this guy right here, 216, I guess I could break him down, but I don't have enough in there. I can break him down. We can look. Let's look to see if there's any. Just because you brought it up, now it's your fault. Blame you. So that's 1,000 times 135, right? We all agree with that. What's in 1,000? We have 100 times 10. We have 10 times 10. Notice they all have 2 times 5, 2 times 5, 2 times 5. So there's no group of 6 there in any of those yet. Right? 135 has at least a 5 in there and a 27, I believe. No. 27. And then that's 3 and 9, which is 3 and 3. Notice I have a group of 3, a group of 4, and a group of 3. So I don't have any that have groups of 6. So I can't even break him down. Okay? Does that make sense? Okay? So our answer here is, to be honest, just right there. Should we do another one of those? Okay. So let's do the square root of 5 times the 4th root of 3. Okay, square root of 5 times the 4th root of 3. What the heck? Is that your machine for the day, Ab? Is that your machine for the day? Wait a minute. Wait a freaking second. What is 5 being raised to? What power? To the second? Nope, I have 1/2, right? How do I do that? Oh, okay. This is 3 to the 1/4. Where does 2 and 4 meet up at? Wait, Matt, are you good? I can help you better than he can help you. Because I know my shit. What the heck? You would ask him, but you won't ask me? Okay. Can a 2 look like a 4? Yeah, so this is just simply 5 to the 2/4 times 3 to the 1/4. Right? Like radicals. So this would be the 4th root of 25 times the 4th root of 3, which is the 4th root of 75. Okay. The foot, what's in 25? I mean, what's in 75? 25 times 3, right? What's in 25? 5 and 5. I'm broken down. I got a 5, a 5, and a 3. Do I have a group of 4 anywhere? I don't even have 4 things. I only have 3 things to use. Right? If you can, yes, because that's simplification. Hip, hip, hooray! Super! Is it the same today? See, I always like that. If I say super feeders are here today. See, that's what I do. I'm a really scoundrel. Yeah. Maybe simply. Hello, where's mine? Yeah. I can't believe you didn't even think of me. Just get a lemonade. Pick a berry, with raspberry, and put all the rice together. Not that long diet. Yeah, I feel. Never, ever. Sorry. Okay, I think that's pretty good. You know what? Yeah. It's a slightly different red wine.
You like black one? You don't mess the hell up. If you had like real good black one, what black one?
Which one is a black one?
Like Aussie. I've had the Aussie one. You
Great.
like it?
Okay. Hey guys, hey. Hey, you're gonna work with me right now. What?
That's still dumb.
Well, I mean, if you can eat it, I guess. Well,
If I can eat it?
I think you'll eat like 3 minutes of it. Or is it?
These are those spicy hot Cheetos.
No, these are just like.
Takis?
Yeah.
Those are huge ones.
Yeah. It's just like wine. I mean, not one, but
Here's his 3 right here.
Muslim. Now, go on.
Good.
Now, man, my wolf. Now I'm full. Had 2 pork plates, some chicken, some salad, 2 potatoes. Are you a wrestling manager? Boy, Troy, I forgot. What's in 20? Do you have a boy Troy on wrestling? Used to? You do, what's his name? Leroy? Okay. Group of 2 right there, do you ever see it? It is reduced in. He's still there. I just broke him down right there for a moment. And I just replaced it back in. See how I stood up for you? Make you stay in class?
Yeah. Well, I was even thinking, I was like, well, I kind of need to have to do my work down.
You're telling me. With a screwdriver. Ooh, that tight. I would have
These guys own.
All right. You guys are totally different than
Yeah, we'll do that.
my first period. My first period, they won't say a damn word. I'm not kidding. I wish people would understand it, but now he's like, oh, bottles are not recyclable. Now, what does 4, 2, and 2 Krista all have in common? Lots of you guys are Krista.
Oh.
Okay, so they all have a 2, right? So I get 2 minus root. I divided them out. Just like if you had 4 divided by 2, isn't that 2? If you have negative 2 root 5 over 2, don't I get negative root 5? That's all I did. Hey, how are you, brother? Good. You man over here?
Thank you. Have a good one. Bye, Adrian. I try to say hi to a lot of them. I just don't know their names. Like my man. Oh, I just lost his name. Oh, everybody remember the kid in the classroom in the picture right there? His name was not Birdie. He was a close kid. He called me silly cow. Bad so bad. Yeah, she did. Do I have a headache? This guy already did this before. We guys are being very How many rompers do you have? You got a lot of rompers, man. No, that's all right. I'm just, how do you get them? Would I look good in a romper? I think I look pretty good. What do you got?
So with this February center at into the fourth, or is that not even the fourth?
I'll explain this. What you doing? Let me teach people. Let's break stuff down. And we are looking for group stuff too. We have it right there. Now, a question for you guys. Not saying that I have any pull in this whatsoever, because I don't anymore. Last year, for Christmas jars, they did the 1 hour lunches, correct? Would that still be enticing?
No.
Why? Exactly. That was my thinking. I agree, because last year was 30 minutes and it makes a big difference. It's just our Christmas contribution. And so we collected in these. It is what it is. You know?
I didn't even see it. It's really short.
Then you need to get there quicker. Bust through those. They were always a full hour. They're actually an hour and 5 minutes. Because there was an hour for the lunch and 5 minutes for traffic. Anyway, onward. I'm just curious. I don't know. I think they're thinking that, but I think somebody should tell them that it's probably not as motivational anymore. Yeah. I thought about seeing if they could let you guys maybe have one early out Friday a month. Well, you got to be realistic, brother. This is true. I used to. That's why I'm in this room. Okay, now let's bring it. Oh, sorry, the 3's still in here. Okay. A to the 6. 6A. So I got an A. I feel like I'm in Philly. Right? 4 candidates. Notice there's 3 groups of A's, right? So an A comes out, an A comes out, an A comes out, which is A to the 3rd. Now, you guys got to remember, I've already inducted you into my math cult, haven't I? There's 2 math cult chants that we have. Huh? Differences, well, there's 3 then. Differences for going to conjugate pairs. Differences for conjugate pairs. Okay. But remember, we had jump the line, change the sign. That's one of my math cults. Exactly. Okay. Next one. What's the other one? Even root, odd power. Even root, odd power. Yeah. People chant. Okay. So notice I came out an even root. A to the 3rd is an odd power. So therefore, remember, we have to do absolute value. Because I do not know what A is. I don't know if A is -2. unless it says in your textbook that assume the variables are positive, we can't. No problem. And we don't want negatives underneath an even root, do we? So what an absolute value does is makes it positive. Okay, so once again, let's look at this. I'll explain to you. Okay, so imagine if I told you, Britt, if you're just bloody dog, square root of 9. What is your answer? Technically, it's 3 or negative 3, right? But I'm not solving because we just usually say it's just 3. But if it's an A value, I'm actually looking for a specific value. So think about this, young lady. A squared. Square root of A squared is A. Well, what if that number was negative 3? Negative 3 squared is 9, right? So is 3 squared is 9. Which one do I know what it is? I don't. So therefore, I absolute value that, and it just takes care of it, meaning it's always just going to be A, or in our case, 3, if that was 9, right? Does that make sense? Now, why don't I have to worry about it if it comes out like, for example, like this, the square root of A to the 4th. What's the square root of A to the 4th? Why don't I have to worry? That came out of an even root, but he is an even power. Why don't I care about him? No matter what, it's always going to come out positive because anything raised to an even power is always a positive result. So I don't have to worry about it. And it's even root, odd power. Coming out of an even root, it comes out an odd power. Only with variables. Okay? Yes.
Odd root and odd power.
That's completely fine because can't odd roots be negative? Like the cube root of negative 8. That's fine. Cube root of negative 8 is negative 2. It's okay to be negative underneath odd roots because a negative times a negative times a negative will come out negative, won't it? So it's okay for it to be. But is there any way for it to ever become negative underneath an even root? No. Hence my evil chant of even root odd power. Answer your question? Answer your question, Brent? Okay. Billy Dodgers. Ooh, I love that. Ooh, yeah. That's all right. We are losing a lot of time. We still got one more unit to do. Oh. That is true, my friend. You are correct. Oh, what the hell? That's a B. What? 27a squared b to the 5th times 4th root of 6a cubed b to the 6th. You have missed any more school during my time? You heard me.
No, that's right. I learned my lesson.
That's right. A to the what power? 5th. B to the 11th. Like roots, I can multiply everything underneath them, right? Now instead of having them two separate, now I'm just one, and I just break him down. I'm looking for groups of 4, right? Guess what 162 is, guys? 27 times 6. Don't know how I knew that? Right there. 3 times 9. 3 and 3. Not a group of 4. But what's in 6? 3 and the 2. Look right there. What do we find? A group of 4. But that lovely tooth, he felt a little left out.
Right, Joe? How many times can 4 go into 5? Once with 1 remainder. Because if I had that, that's A. There's one group of 4, hence why he's coming out. And 1 come over here. So how could I do that without having to write those out all the time? Is just divide. Right? I have 4 can go to 5 one time, if I have 1A outside, with 1 remainder. Right? Okay, yes, ma'am. A to the 5. I have A squared times A cubed. Does that make sense, Chris? Now, how many times can 4 go into 11? Twice with 3 remainder, huh? Is that my answer? If that was worth 4 points, I'd give you 3 on that. Absolute value around who? Just the A. Because he came from an even root, and he is an odd power. Even root, odd power. Get it in your head. You come pull it in my coat. I will make a drink punch. The Kool-Aid. Root. It doesn't matter. Anything out of an odd root is completely fine wherever it goes. Okay, one more of these guys, then we'll go on to the next section. I hear you're bleeding. You're going to hell. I can't die. I do. I take it as one.
I was like, wait, it's serious.
He's all like,
No, that's my house. Like, yeah.
oh, it was actually a driver.
Yeah?
We have 9 on A.
Number 8.
Alex?
Just like with multiplication, if they are like radicals, I can divide, which I want to do before I do anything. Okay? So what does 54 and 2 have in common?
A 2. So 54 divided by 2 is 27. Still that negative 2's out here. Okay? But I got 1A up top and B cubed. I'm going to have 4 B's down here, so that leaves me 3 of them still downstairs. Would you guys agree with that? Oh, damn, A. Darn A. It is a bad A. But my mom said that when I was moving. That bad A butter trucker. Name that movie. You're a bad A. Oh, what does it say? I don't take no one.
Oh, okay.
I thought of
Running.
Cool Running. Bad mother that don't take it from no one.
Don't take no lead from nothing.
Yeah.
I'm confused on
I divided. So 54 divided by 2 is 27. Just like, same thing, like here, right? Because isn't division just a multiplication in a way? That's what I'm doing. With me? Okay. And then I did A divided by A to the 4th, A to the 3rd down below. Now we're going to simplify. What is the cube root of 27? 3, right? We could break him down if you need to. But some of you guys might not know that it is. Does that make sense why it's 3? But I already had a negative 2 up here, didn't I? So negative 2 times 3 is negative 6 on top. And what's the cube root of A cubed? A. Am I done? Do I need absolute values?
No, because it came out of an odd unit. I just watched it the other day, that's why.
Oh,
All right. 7-6. Even root, odd power. Even root, odd power. 7-6. I need to go people. So, with that being the case, I would like you guys to graph this. Okay? With that being said, if you don't know what a graph looks like, what do? Pick some points, right? Now, do I want to pick like 3? Could I pick 3? Yeah, I could. I could pick 3, square root of 3. That's okay. It's just not something I know what the root, like simplified decimal is. But is it a number? What's a number for x I probably want to pick? 9's a good one, right? What else is a good one? 25 and those. Okay, so I do a little t-chart where this is x, this is y, and like you said, 9 might be a good one where that's 3. Pick some other points and then graph it for me while I heard you will use the rest. Resume recording. I saw some people pick some values. I saw 100 being picked. And you get 10. That's a good one. Do I want to do 100 being picked one? No. What's not a good one? 1's a good one. I get 1. 16 and 4, you mean? Yeah. 4 and 2. Anybody else a good one? Caitlin? What am I missing that you have that I don't have up here? Oh, I can't have a negative, can I? Because you guys have not learned about imaginary numbers yet. Supposed to. 25 is a good one, but I'm not going to pick it. That's why I tick mark 2. 0 is the one we're missing that a lot of you guys probably forgot. Right? Isn't 0 a perfect square root as well? Yeah. Okay? So when I plot this, this is what I get. 0, 0, 1, 1, 4, 2, 9, 3, and I'm going to stop right there. So you had your graph going up, right, Carter? But it's just going to continue to go down. So it's very close. Yep, because the next one's going to be 16. It takes a lot longer to go for everyone it goes up, right? You guys agree it's taking a longer time to get up there. I mean, 100 tick marks just to get to 10. 121 tick marks just to get to 11. It's starting to grow larger and larger. Does that make sense to everybody? Quadratically.
Oh, quadratic.
Anyway, is everybody there? Okay, so that's what the graph of this looks like. Now they're going to ask you for the domain. You guys remember what domain means? The x or y value. The x value. So the domain. Looking at this graph, how far left can I go? All the way to 0. Can I go anything less than 0? Why can't I? Because then that makes me an imaginary solution. So we go from, notice we have 2 different types. We have set builder, remember, where we'd go x such that x is greater than or equal to 0. You guys remember that? The piece of poo that is? You have a poo-poo map, one right there. And then, the next one. We had interval notation. Where do we start? 0. Where do we go to? Infinity. Not beyond. We're not like Buzz Lightyear and full of crap. No such thing as beyond infinity. Then the definition of infinity is just not right. It's a concept. Tristan, where do you go? Not a number. It's not. Okay, so that's our domain. But they also want us to talk about our range. And I'll be honest, guys, I'll never ask you to write your range in set builder. How low does this graph go? 0. Me and him were right on it. And how high does it go? Infinity. That would be the y value. So remember, this is the y value. This is the x value. Dollar bill. Work a little hard. Soul driving. I'm writing both just for the fact, once again, I don't know what the final looks like. Remember how we talked about that? And so I'm always just trying to prepare you to get both types of notation. But I like interval notation, and I hope that because I believe that's the one that's best. But once again, I'm not sure. If I talk to Spock next semester, I tell you exactly what I want. You know what I mean? But you never say in the final. That's kind of it. You know, so I might as well prepare you for both. Hey, so guys, what's this going to do as a graph? We should learn this in the past. It's a shifter. Whoa. Hey, look. Why was it the right one? There's a freaking -4 up there. He was right, but I want to know why. The equation does tell us, but does anybody know why you're going to the right portion? Somebody actually told me in my first period. I was really excited. See what that? It does make your x values increase. Never taught you why. You just got to do opposite what you see here. Right? Guys, what value would make that inside 0? So this would make this guy 0 is 4. Remember, here was my parent function. This is what I call my parent function. 0, 0, 1, 1, 4, 2, 9, 3. I could use some more, but once again, too many tick marks, right? This gives us a good graph of our parent function. So, what does this graph do compared to this graph? Well, as we just said, it shifts it to the right 4. And the reason being is, I'm basically asking, when will this guy equal 0? Oh, it's when it's 4. So notice I went from 0 to 4. So what did we do? We shifted that to the right 4. I'm going to ask, when does this guy equal 1? Oh, when it is 5. And 9 and 13. You guys see how I moved all my x values. Now you might want to put a little note in your notes, that anything on the inside involves your x value. Anything on the outside, which we haven't done yet, we can make it. Let's make this that. What the heck, we can make it. Let's put a +1 here. What is that? That's not a horizontal. It's a vertical. Because we just did our horizontal, right? So, notice, watch this, guys. If I plug this in, 4, what's 4 minus 4? 0. Look how I got right back to him. Well, what's the square root of 0? 0. Do you see how he won't change his values on any of these? It is not an 8. Oh, yes, it is an 8. And it is a 13. Okay. Notice watch plugging an 8 in. What's 8 minus 4? 4. What's the square root of 4? 2, so that's why I still have the same value. Now I go to, okay, well that's not the whole graph that they asked me to graph, is it? They asked me to graph this guy. So tell me, guys, what's different from this guy to this guy? Notice I'm just going piece by piece. It's adding 1 to who? To the y value. So watch what will happen. I'm going to plug in a 4. Ready? 4 minus 4. Oh, that got me back to my x's. The square root of 0 is 0, so that's where I'm at, right? With 0, but then, where's that plus 1? 0 plus 1, so therefore, do that 1. So it moved my y value up 1, didn't it?
Okay? So let's go ahead and plot this now. No, it's a 9. No, it's an 8. Damn. It's an 8. It is an 8. It's an 8. Straight up 8. I know it's an 8. I keep writing it, but it's an 8. So 1, 2, 3, 4, I'm at 1. 5, I'm at 2. 8, I'm at 3. 13, I'm at 4. Okay. What's our domain? It is not 0 to 1.
Oh, wait.
4, isn't it? Everybody see how we started at 4 and we're going to infinity? Set builder would be x such that x is greater than or equal to 4. Yes, sir.
Wouldn't that be like
Bracket, it would be. I'm struggling, man. I'm struggling. What's my range? How low does this go? How low does the graph go? Goes to 1. How high does it go? Infinity. Not beyond. Okay, I'm going to show you a quick way they average, because on your homework today, they're not going to necessarily ask you to graph every single time. Okay? But they are going to ask you for your domain sometimes. Just your domain. Let's try another one. Ladies and gentlemen, what would be the domain of this graph? Just the domain. To what? Infinity. Why? Because it does shift me 3. But basically, what can we never have underneath a radical? We can have 0. It's okay to negative 3. We don't want it to be negative. So don't we want the stuff underneath the radical to always be greater than or equal to 0? Correct? So solve it. If I solve that, what do I get? X has to be greater or equal to 3, which would be 3 to infinity, or x such that x is greater than or equal to 3. Well, a little bit. The headache? Why? No, we're actually in bracket. What points can I pick? Because once again, I don't know what my graph looks like, so we're going to start off with our parent function. What are we going to put in for x? What's a nice, perfect cube root? 27. Do I want to do 27 6 marks still? No, that is a good one. I don't want to do it, though. 8's a good one. 0's a good one. 1's a good one. Anybody else? 9 is not a good one. I mean, is there a cube root of 9? Yes, but I don't know what it is. -1? What's the cube root of -1? -1. What's the cube root of -8? -2. This is kind of what I call my parent function. It gives you a good value. Okay? So just the same thing. What is this plus 2 going to do to us? Is it our x values or our y values? Our x values, huh? So therefore, we're going to go to the left or the right? We're going to go left how many? 2. So that's -10, -3, -2, -1, and 6. And it gives me -2, -1, 0, 1, and 2. And if we don't believe me that it does give me these values, can I check it? Let's pick -3. What's -3 plus 2? -1. What is the cube root of -1? -1. It does work, doesn't it? Okay, so now I'm going to go to the last step. It's the cube root of x plus 2 minus 3. And notice all I'm saying is what's the difference from this guy to this guy? Going down 3, so is that x's or y? Y, so I still have my same x values, right? So my y values are going to go down 3. So therefore that's negative 5, negative 4, negative 3, negative 2, negative 1. Should we see what this guy looks like now? Negative 3 is negative 3. Negative 2 is negative 3. Negative 1 is negative 2. That is what a cube root looks like. What's its domain? Negative infinity to infinity, because it keeps going, huh? Doesn't it make sense that it should be negative infinity to infinity? Because I can plug in both positives and negative numbers into a cube root, right? So my domain is, once again, negative infinity to infinity. Or we could say x such that x belongs to the real numbers. Maybe I'll write it over here. Domain is negative infinity to infinity. That's the interval notation. Or it could say in the set builder, x such that x belongs to the the real numbers, like in R. Like this. Okay. Yes, sir.
So at the point where it would start to curve out, the other way would be negative 2, negative 3, just because instead of rates that they like
They're
go off of each other,
yeah.
it's always the same unless there's something on the front of it.
Okay. What's the range? How low is he going? It's taking him a while, but he's still going down to where? Negative 8. How high is he going? He's still going to infinity, but it's going to take him a while, huh? Yeah. We can never change the domain. That's a great question, Britt. So what she just said there is always going to be good there for a cube root. It's actually there for any odd root. Any odd root will always be negative 8 to infinity, negative 8 to infinity. But anything into odd root is that. Even roots are when I have to restrict myself. Does that make sense? So sometimes on your homework, it might be what's the domain of a cube root, and you're like, oh, it's negative 8 to infinity. That usually doesn't work. But an even root, remember that whatever's underneath there. Okay, I got one last example. This guy's a little bit tricky. Okay, here once again is my normal parent function. What do you guys, oh, sorry, we can make this look like this as well, can't we? Do you guys agree that's the same thing? It does flip it, but which way does it move me? I see a +2, which way does it move me? Does it move us left too? No, it actually moves us right. Let me show you the reasoning why, okay? Because what it does is this negative negates all these guys first, right? So it goes 0, -1, -4, -1. But then, what does that tell me to do? Shift this to the right. Because isn't this and this the same? If I distribute it through, it'll make it the same. Let me show you what I would do, not just try to be so confused. How did I find the way I shifted? I set the inside equal to 0, right? That's really what I did, didn't I? I'm just going to add 2, add x over. Oh, 2 equals x. So that shift moved me him over by 2.
oh, I'm gonna take him and see when it equals 1. I'm gonna subtract the 2, divide by negative 1. When does this equal 4? I can add the x, subtract the 4, negative 2 equals x. And then when does this equal 9? I'm going to add the x, subtract the 9. Negative 7 equals x. Oops, sorry guys. And there it is. And then I'd be able to graph that. If you guys don't mind staying just for 30 seconds, I can hurry and graph it and then give you your homework. So really quickly, this would look like 1, 2. 1, 1. Negative 2, 2. So, what's our domain? This one's a little bit different. What's our domain? Negative infinity to 2. What's our range? 0 to infinity. Homework really quickly. In that back section again of 7-3 and 7-6, you're doing, I think, 37 through 61 odd. Just basically the odds of 7-3. And I believe it's 101 through 113 odds as well. And I think it's on page 603 and 606. Check your book though. Remember how we've just been going back to the review section and picking those odds mostly in those sections, right? Okay. Hey guys, thank you. Remember, next time we will start with the quiz, okay?